Our math warm-up today consists of ordering decimals. I have 4 problems here for you. Let's take a look at number 1. We have 3 decimals listed. I'd like you to pause your video and write those decimals from smallest to largest. So one method that we could use to place these decimals in order is to actually place them in a T-chart, which I have done. And you'll notice that I placed my decimal point here right on the line in the middle, and then I lined up each of my digits in the columns like so. You'll notice, and I think this was a mistake when it was typed, that this says 013 over here. I think it was supposed to be 0 and 1300ths, but we're going to go ahead and leave it as that and place these in order. So if I go to place these in order, I am going to take a look at all of the places where I do not have digits, and I'm going to place a 0. And then I'm going to go back here and place zeros so that all of these have the same number of digits. Then I'm going to take a look at the first column on the left and notice that all 3 of those are zeros. So I'm going to cross those out. And I come to the next column, and my largest number is a 1. So right there tells me that that's probably going to be my largest decimal. So I'm going to cross that one completely off because I've used that. So now I'm going to look at that first column once again, and I have a 0 in both columns, or both decimals. So then I'm going to move to the next column over to the right, and I have a 1 and a 0. So remember, we're putting these in order from smallest to largest. So that means that my 1 and 8300ths would come next. I'm going to cross that out, and that leaves the 0 and 7900ths as my smallest decimal. So this is just one method that you could have used. You don't have to use a T-chart, but I'm just giving you that option. So let's take a look at problem 2. Go ahead and pause your video and put those in order. So looking at this section, number 2, for those 3 decimals, you should have written 0 and 2400ths as the smallest, 0 and 6700ths as the next smallest, and 0 and 8900ths as your largest. Go ahead and pause your video and complete number 3. Okay, for number 3, this gets a little tricky because we have some decimals with 1 digit and some with 2 digits after that decimal point. So we're looking at 0 and 900ths as being the smallest, and then would come 0 and 1500ths, and then 0 and 3/10ths. Now remember, that would be 30/100ths if we place that 0 there. So again, this would be kind of like thinking that was 9 cents, 15 cents, and 30 cents, if it helps to think it like money. Okay, last one. Go ahead, pause your video, complete that one as well. Now with this 4th question or problem, we have 3-digit decimals and some 2-digit. So we're looking for the smallest. So again, this is one of those times where I feel like a T-chart would work the best because you can assure that you line up those decimals. So if we place those in the T-chart like so, and make sure that we line up all of those decimals, and then we're going to come back and plug in the hole, right, that we have right here, and just place a 0 in that spot. And so we'll look at that first column. They're all zeros, so we're going to cross that out. We move over to the next column to the right. Guess what? Those are also all zeros, so we're going to cross those out. So now we're going to look at the 6, the 5, and the 7. So the smallest one, the smallest digit there, is the 5. So that's going to be my smallest decimal. And then my next smallest will be the 6. And then, of course, the 7. And there you have it. See how easy that was? Okay, our math message today involves taking a look at the grid that is here on the right. And it's actually a town map. And we're going to use those grid lines to represent the roads in the town. So we have a little problem here. It says Ben is going to walk from school to the grocery store to buy an after-school snack. What is the fewest number of blocks Ben will have to walk to get to the grocery store? So what I'd like for you to do is pause your video and kind of look at that and work it out. Try some different routes and see if you can figure out what is the fewest number of blocks Ben will have to walk to get to the grocery store. So you may have noticed that the school is right down here at the bottom corner where we have our origin, right, for our grid. That's where our two axes meet at the 0 point. And the grocery store is here. So if you have taken this and tried to figure out how far it is, so let's say that we just decided to go straight up. So we're going to travel all the way up to here. And then we're going to go across to the grocery store. If we count each one of those sections from here to here, that would be 1 block. So we're going to go, there's 1, 2, 3, 4, 5 blocks up, and then 6, 7, 8, 9, 10, 11 would be our total if we went that direction. If we decided to stay down here at the bottom and go over and then up, again, we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Again, we get 11 blocks going either one of those ways. So it's going to take him 11 blocks to get to the grocery store. We can't go at a diagonal. That would probably be the shortest route, but we can't do that with a coordinate grid. We don't do diagonals. So our answer to that question would be 11. So I hope that you figured that part out. Now, what would happen if I asked you to name each of those locations with an ordered pair? So the school would be 0 and 0. And then if we looked at the grocery store, remember we look at the x-axis first, and then we name the y-axis. So that's going to be 6 and 5 would be our coordinates there. Nice job. Today's lesson is a game called Hidden Treasure that we are going to use with coordinates today. So you might be wondering, why are we doing this lesson? Why are we doing a game called Hidden Treasure when it has to do with coordinate grids? Well, the reason that we're doing the game today is because this game is going to help you become better at problem solving with coordinate grids, finding and locating ordered pairs, and writing ordered pairs. So how are we going to do that? Well, right here on this screen, I have got the rules for the game. And we're going to kind of take a look at those, and then we're going to do some sample plays so you can kind of see how it works. So this is a 2-player game, as you can see up here. And our skill is plotting ordered pairs and developing a search strategy. So if you've ever played the game Connect 4 or Battleship, that's another good one that helps with coordinates. So the object of this game is to find the other player's hidden point on a coordinate grid, which is similar to Battleship if you've ever played that. So here's our directions. Each player is going to use 2 grids, and I'm going to show you what your game board will look like here in a second, but down here you can kind of see that there's 2 grids. Each player is going to secretly mark a point on his or her grid 1 using a red, it says E tool, but you can use whatever color you want, but it just needs to be a different color. These are the hidden points. Player 1 guesses the location of player 2's hidden point by naming an ordered pair. To name the ordered pair 1, 2, you're going to say 1, 2. If player 2's hidden point is at that location, player 1 automatically wins. If the hidden point is not at that location, player 2 marks the guess with a different color on his or her grid 1. Player 2 counts the fewest number of square sides needed to travel from the hidden point to the guessed point and tells it to player 1. You're going to repeat steps 3 through 5 with player 2 guessing and player 1 answering. Play is going to continue until one player finds the other's hidden point. So we have an example here. Down here where player 1 marks a hidden point at 2, 5. That's how we would say that. Notice that they marked it in red, so you can just choose a special color for yourself and mark it. Player 2 marks a hidden point at 3, 7. So then we take a look here at this part where we have player 1 guesses that player 2's hidden point is at 1, 2 and marks it on grid 2. So notice that is here. This is the grid 2 where they've marked it. Player 2 marks the point 1, 2 on grid 1 and tells the player that 1, 2 is 7 units away from the hidden point. So remember, the hidden point with the original one was 2, 5. The hidden point on this one was 3, 7. So if we count how many spots that is, that would be 1, 2, 3, 4, 5. Remember, they guessed 1, 2. So that would be 5. And think of the math message that we did with the blocks, right? How many blocks to the store from the school. So you're looking at each line, I guess if we want to call it a line segment or a part of a square. Each part is considered a section or a unit, okay? So the goal of the game is to try to figure out, of course, where your player, who you're playing with has, where they've marked. What's the hidden area? So this is what your game board will look like. You'll notice that it'll say grid 1 and then grid 2. Grid 1 is where you're going to place your hidden coordinate. So let's say that I pick red right now and I am going to place my hidden coordinate right here, right? And I'm going to write 1, 6, right? Because that is my hidden spot for my partner to try to figure out. So then my partner is going to guess where my spot is on my grid. So let's say that they guess 4,4. So you would place a dot here. You would write 4,4. And then you would tell them that it is how many units away. Say, no, I'm sorry, you did not guess. It is, and then we look here, like 1, 2, 3, 3 units that way, 1, 2 down, but we can just say 3 units away. And then they would make another guess, and you would continue until they guess or you guess theirs.